Now the question says, Earth has a mass of 5.97 times 10 raised to the power 24 kilogram. That's the mass of the Earth.
Okay.
So you would write all the things being given. The mass of the Earth is equal to 5.97 times 10 raised to the power 24 kilograms. And the radius of the Earth is 6.38 times 10 raised to the power 6 meters. This is for Mars, right? And Saturn has a mass of what? Of 5.68 times 10 raised to the power 26. It has a radius of 6.03 times 10 raised to the power 7 meters. Now find the weight of a person who is 65 kilograms on the following location. Now the weight of this guy on the Earth, on the surface of the Earth, will be what? We don't. That's what we're looking for.
60. Oh, okay.
Because the mass remains constant, as you know, we did that in lower grade physics. The mass would never change. The amount of matter in you will never change. But what would change in you is the weight. So, and
what's the difference between mass and weight?
Mass is the amount of matter in a substance or in you.
Like bones.
Yeah, but weight is a force of gravity on that mass. Let's say, for example, this is a box. It has a mass of 5 kilograms, right? On the Earth, we know normally the force of gravity is 10 Newton per kilograms. Now, what would be the weight of this guy with a mass of 5 kilograms? It's going to be 5 times 10 Newton per kilograms, and it's going to give you what? 15 Newton. Because the mass is this, it doesn't change, but the force, the weight is a force of gravity on the mass. Is that understood? That pulls it down to the center of gravity. So, but now we're not saying, okay, we don't know what the force of gravity is. We're only given mass and the radius. We are the ones to find the force of gravity on the Earth by ourselves. Okay. So how do you find it? There's a formula given to you here. The force of gravity, it says when you have the gravitational field strength, that's what you're looking for, right? The gravitational field strength, which is represented by what? By G, depends on what? It depends on two things. What are they? Depends on the mass and depends on the distance. It depends on what? The mass and the distance. So this is the reason why you would say the formula Fg. What is Fg? That's a force.
Force of gravity.
Of gravity equals to what? G M E over 1 over R squared. Now, as you know, from what we understood, we understand that what? We understand that force, look here please, force is mass times what? Acceleration. Isn't it?
Yeah. And
I already mentioned to you that the acceleration, which is acceleration due to gravity, is equal A. So you can use that as well. You can use that as G. So if you want to find this G, you can say this divided by M, this divided by M. Is understood?
Yeah.
So it's going to give you this constant days. So as acceleration due to gravity is going to be what? Fg over what? Over M. You get what I'm saying?
Yeah.
And remember that Fg is here, isn't it? So Fg is the same as this. So you're going to plug in Fg, which is in the place of GME R squared. So you would say, now we want to find what? You want to find the force of gravity. So you would say G equals to what? Fg will stand in place of this. So which is copy to G, M mass 1, mass 2, over what? Over R squared. But remember that here, the Fg is all of this, and this over M, right?
Okay.
Then M times this. So it's going to give you what? G equals to G M M E over what? Over the mass times the radius squared. Remember that one m can cancel another one. So you're going to have remaining g equals to capital G me over r squared. So this is a formula for finding the force or the gravitational field. Is understood. So we need to find the gravitational field strength of the Earth first. So what the values have been given, we know that G is constant. Can you remind me what the value of G is again?
G is.
You should not forget. Remind me without checking the book. G is 6.673. If you master all these things, G is what? G is the capital G is 6.673 times 10 raised to what? Negative 11. Good. So you're given the mass to be what? The mass of the Earth is given to be 5.97 times 10 raised to 24. And you're given the radius to be what? To be 6.3 times 6.38 times 10 raised to what? 6 meters. So you're going to plug in the value. So let's give space here. So the gravitational field strength, which you want, is what is 6.673 times 10 raised to negative 11, right? Times 5.97 times 10 raised to what? 24 over what? Over the radius squared. 6.38 times 10 raised to what? 6 all of it squared.
Okay.
Is that understood? So I said to make your life easy, you will multiply the values first. Ignore these indices first. Now, if you use a calculator,
it'll be 39.
that's right. Let's use a calculator and say 6.673 times 5.97 is going to give you 39.8. 39.1.83. So, but remember that whenever you're multiplying, you add the what? You sum up the values of the indices times 10 raised to what? 10 raised to negative 11 plus 24. So, which is the same as 24 minus what? Minus 11. It's going to give you 31, right? So the meaning is you're going to have 39.83 times 10 raised to the power of what? Power of 13. That's the numerator. Now you saw the denominator. To make your life easy too here, a way to do it is this. Since you have 10 raised to power 6 squared, is the raised to power 6 squared can be written as 6 times 2. It's going to give you what? 12. So that will be what? 10 raised to power 12. And you will square this. You will square 6.38 squared. It's going to give you what? 40.7. It's going to give you 40.7 times 10 raised to power what? 10 raised to power 12. You see that?
Yeah.
And remember, you can also solve this in a very simple way, mathematical way. But let's solve 39.83 divided by 40.7, and that's going to give you what? That's going to give you 0.9786 times 10 raised to power what? You will say 13 minus 12 because you're dividing it. 13 minus 12 is 8. How manage? You did not square 10 raised to power 6.
Yeah.
So it's going to give you what? It's going to give you 0.979 approximately times 10 raised to power what? 10 raised to power 1.
And then you move the.
If you move the 0, what would you put here?
9.7.
9.7 times what?
Times 10 to the 10 times 10 to the power 1.
You know, if you move the power backward, what would happen to the zeros?
To minus. Oh, okay.
10 raised to power 1 is normally as 10. You know that?
Yeah.
So you would say 0.979 times 10. Times what? Times 10. And that's going to give you what? That's going to give you 9.7. 9.78
Times 10.
That's going to give you this is the value of the gravitational field strength for what? For the Earth. This is 9.7 what? What is the unit?
9.7 times 10, right?
No. You said 0.979 times 10 raised to power 1.
The unit is kilogram.
No. It should be Newton for kilogram. Is understood. So now this is just to find out what the gravitational field strength of the Earth. Now, what is the question? What is the weight of a person with a mass of 65 kilograms on the Earth? So let's find space here so that we can finish off the question here. So the second stage is, now we've been able to find out what the gravitational field strength is equals to what? Is equals to 9.78, right? So the mass is what? The mass is 65.0 kilogram. And what we find in the weight. The weight is going to be what? It's going to be mass times what? Times acceleration, which is represented as g. So it's going to give you what? It's going to give you weight equals to what? Equals to 9.78 times 10 raised to what? Times 65. Yes, do it. Let me see. What is going to be the answer? 9.78 times what? Times 60. Hey. That's going to give you what? It's going to give you 635.7 what? Newton. Let me make you understand how to get it. The unit of this is Newton per kilograms, right?
Yeah.
And you multiply this by what? By kilograms. You listen to me? So this will cancel this. Then you're left with Newton. So the answer is what? 635.7. So what did you get?
I think I stopped at 9.
So now we've been able to solve for the first one. Now here it says, what will be the weight of this guy at the following location? 100,000 kilometers above the surface of the Earth. When the distance is 1,000 kilometers above the Earth's surface. What is going to be the weight? So how do you solve that?
Above the Earth.
Yeah.
Above the surface, it's Earth. It says above the surface, if Earth.
Above the surface of the Earth. Let me solve it. Now it says okay, when you have the Earth has a mass of this and a radius of this. So when you have the person, what is the weight of this person of mass 65 kilograms? When he is standing in a location which is 100,000 kilometers above the Earth. And what would you say? The distance is the radius, right? The radius we have before is what? Is 6.38 times 10 raised to what? 6 meters. Now, when it's standing 1,000 kilometers above the surface of the head, then that means you're going to add this with what? 1,000 kilometers. Is understood? But remember, you have to convert the kilometers to meters. And 1,000 meters equals to 1 kilometer. Then you're going to have to multiply this by what? By 1,000. So that gives you what? 6.38 times 10 raised to 6 meters plus 1 times 10 raised to what? 6 meters. Is it okay?
Okay.
So to find a combination, you would add this up. It's going to give you 7.38 times 10 raised to 6. Since you have addition here, what would you do with the raised to power?
Do you mean 1 plus 1,000 or times 1,000?
Plus, no, times. You're adding it together.
Then why did you put times on?
1 times 10 raised to 6.
No, here.
You add here, you multiply this times this.
Oh, okay.
Is that understood?
1 million.
So it gives you 1 million. So how would you do this? This plus this.
Okay.
It's going to remain the same 10 raised to 6. Is that understood? It's not going to change. You get what I'm saying?
Yeah.
If you sum up things, which is actually the same indices, it's going to remain raised to 6. Is that understood? Meters. So now we've got the radius to be this. Now what else do we want? Remember the formula is what? Is capital G, right? ME over what? Over R squared. And that's what.
But doesn't this cancel this? The 6?
No, it's not going to cancel it.
Only if you times it.
Yeah, it's only if you times it, you sum it up.
Oh, okay.
But if you're adding it up, it's gonna remain the same.
It's not gonna be 12.
It's not gonna be. It's gonna remain 6. So what is the formula here? GME. Let's go back and see what the formula is. F. This is what I call it. The force of gravity is gonna be what? The force of gravity is this, right? And we already got this to be what? What is the value of G?
Value of G?
Yeah. The value of G we got 9.78. That is the force of gravity.
From the other. Okay.
9.78.
Yeah.
9.78 meter per second squared.
Yeah.
Meter per second squared. 9.78. G equals to what? 9.78 meters per second squared. 9.78. 78 meter per second squared, right? So you will plug in the values. The G is known to be what? 6 point, tell me.
6.7. 6.673.
673 times 10 raised to what? Negative 11 times what? What is M? What is the mass? 5.97 times 10 raised to what? 24. Over what? Divided by 7.38, right?
No.
Yes, the total radius.
39.
The radius.
The radius, okay.
7.38 times 10 raised to 6. All of them being squared equals to what? Equals to what we're looking for. We're looking for the weight, right?
Yeah. Yeah. Look. The weight.
Yeah, I'm trying to find the weight.
We didn't give it. Oh, you didn't. So.
It gave us this. Weight is force equals to mass times acceleration due to gravity. Right? Okay, we're gonna find new acceleration due to gravity because it's not gonna be the same with 9.8. You know why?
Why?
Because it's 1,000 kilometers above the sea, above the earth. So the force of gravity will change. So that's what we're looking for now. So now let's continue with the calculation. We're finding G. All we're doing now is we want to find what G is. So when we get what G is, then we're gonna plug in the value. So now let's use a blueprint to proceed. 6.673 times 5.97 is what? Fast. 6.673 times 5.97.
39.8.
39.83781. Okay. Times 10 raised to what? Negative 11 plus what? Plus 24.
Plus 24? Oh, it's going to be 13.
Right? Yeah. 39.8 times 10 raised to 13 divided by, now 7.38 squared.
7.38 squared? 7.38. 54.46.
54.46 times 10 raised to what? 6 times 2, which is going to be 12. Is understood. So you're going to do the same. Divide 39.8 divided by 54.46.
39.8
divided by 54.46.
Divided by
39.8 divided by 54.46.
54.46.
What did it give you? It's going to give you what? 0.73 times, remember this is division, right?
Yeah.
13 minus 12. It's going to give you what? 1. So this is directly 7.3 times 10, 7.3.
Yeah.
You get what I'm saying? Because you've got 0.73, then times 10 is going to give you 7.3. 7.3 what?
7.3 times 10.
Meter per second squared. So that is the force of gravity around 1,000 kilometers above the Earth. So now we want to find the weight, right? The weight, which is represented by what? By F, is equals to a mass. What is the mass of the person? Equals to mass times the what? The acceleration due to gravity, which is 7.3. So you would say the weight is equals to what? The weight equals to 65.0 kilograms times what? Times 7.3 meter per second squared. Is that understood? Then 65 times this is going to give you what?
65 times.
The answer? Okay, 65 times 7.3. 65, no. 65 times 7.3.
474.5.
It's going to give you 474.5 what? Newton. Now compare this. Look at the weight of this guy when it's 1,000 above the earth and his weight when it's on the earth. Now compare this. This is the weight when it's on the earth. 635.7 Newton.
Lighter.
When he's on the earth is this, right?
Yeah.
So when it's 1,000 above the earth is this. So which is lighter?
This.
When it's 1,000 above. The meaning is the more you go or the higher you go, the less your weight.
And the more down you go,
the more the what? The more the weight. Do you understand that?
What if?
Now you're gonna solve on the surface of Saturn. Yes. Now on the surface of the Saturn, you should have approximately 677. Let me just show how to work it out. The first thing you need to do on the surface of the Saturn is this solution. Is this. The first thing is you're gonna find the what? You're gonna find the force of gravity. This is G_m_e over what? R squared. Right? So, and the mass is given. We are looking for the force of gravity or for acceleration due to gravity. G is 6.673, right? Times 10 to the power negative 11 times what is the mass? 5.68 times 10 to the power what? 26 over what? Over R squared. What is the radius? 6.03 times 10 to the power what? 7. So if you multiply these two, it is a 6.673 times 5.68. That will give you what? 37.9 times 10 to the power negative 11 plus 26. They were did it all the time. So when you have this, you just add this together because the sign is multiplication. So what would you get? 37.9 times 10 to the power what? 10 raised to the power of 15. No, negative 15, right? Divided, remember this is squared. So you're going to break this up. 6.03 squared is going to give you what? 36.36, right? Times 10 raised to the power 2 times 7, 14. So you're going to subtract this later. So you would say 37.9 9 minus 36.3 is going to give you what? 1.6, right?
1.05.
1.6.
It's not 37.
37.9.
I got 38.
Where did you get that from? You multiply this. This is where you made the mistake from. So 1.6 times 10 raised to the power of 1. 15 minus 4, 14. So that's going to give you what? That's going to give you 16. Am I correct? I'm wrong, right?
Yeah.
So let's divide it again. Where's the mistake coming from? Let's do it again. 6.673 times 5.68 equals to 37.90. Okay, that's intact. Divided by 36.36. Oh, sorry, it's 1.04. Where did I get 1.6 from? 1.04 times 10 raised to the power 1. So that's going to give you what? It's going to give you 10.4. 10.4 what? 10.4 kilometer per second squared. This is the acceleration due to what? Due to gravity. Now you're going to plug in the value for what the weight. Now, as I told you, the normal formula is force is mass times what? Times acceleration due to gravity, which is G. Force and Newton, force and weight is almost the same thing because they have the same unit. So the mass is given to be 65 kilograms times what? Times 10.4 meter per second squared. So when you do that, 65 times answer is going to give you what? 65 times 10 raised to power 10.4 is going to give you 676 Newton. Is okay? So now if it says, okay, what is 1,000 above the surface of Saturn? The meaning is the radius is increased by what? By 1,000 kilometers. What is the radius given to you? 6.03 times 10 raised to power what? 7 meters, right? Plus 1,000 kilometers. 1,000 kilometers is the same as 1,000 times 1,000 meters.
Okay.
Is that okay?
It's 1 million.
So that's going to give you 6.07 times 10 raised to power 7 plus 1 times 10 raised to power what? 10 raised to power 6. So when you multiply these two, you're going to get 6.07 times 10 raised to power 7 plus 6, 13. Is okay?
Yeah.
So this is a radius. So now you plug in the value. Remember that you're finding you're finding the weight. So the first thing you do is you're gonna find the acceleration due to gravity when it's 1,000 kilometers above Saturn. So let's go to another page. Remember all these things. Now the radius is given to be what? 6.07 times 10 raised to the power 13. 18.